Hello, welcome to the video. In this lesson, we're going to be looking at section 8.3, where we're going to be analyzing geometric sequences and series. So here it says, how can you recognize a geometric sequence? So when we looked at 8.2, we had arithmetic sequences. We were able to recognize that because it had a common difference. If you took the first or the second term and subtracted by the first term, it was the same value if you took the third term and subtracted by the second term. Now, in today's lesson, we're going to be looking at a geometric sequence where you are going to have what is called a common ratio, which means that if you took the first or the second term in the sequence and divided it by the first term, you would get the same answer if you took the third term and divided it by the second term. And so if we look at these two examples here, if I were to divide 12 divided by 6, I would get 2. But if I were to take 20 and divide it by 12, I would get like 1.67. So since they're not the same common ratio, this is not geometric. Over here, in part B, if I were to take 64 and divide it by 256, I would get 1/4. If I take 16 divided by 64, I would get 1/4. 4 divided by 16, I would get 1/4, and 1 divided by 4, I'd also get 1/4. Since they have the same result as in their division, I can say that this is geometric. So being able to write a rule for a geometric sequence is right here. All right. So you were still going to need to find the first term in the sequence just like you did with an arithmetic, but here you're using the value of r as your common ratio, and it is going to be raised to the n minus 1 power. So if you looked at the example that we did in part B, since they were all 1/4, r in that particular instance would be 1/4, and you'd go about and solve the rule from there. So looking at these two examples, the first thing you got to do is figure out what your common ratio is. So I'm going to go here and take 15 divided by 5 is 3. And I'm just going to double check 45 divided by 15 is also 3. So that is my common ratio. So to find a sub n is going to be equal to a sub 1, which is 5. It gets multiplied by the common ratio, which is 3, and it's raised to the n minus 1 power. The next thing they wanted you to do was find a sub 8. So to find a sub 8 in this case, it's going to be 5 times it by 3, and it's going to be raised to the 7th power because 8 minus 1 is 7. 3 to the 7th power is 2187 times that by 5. I get 10,935. So here's my rule. Here's what my result would be at a sub 8. Looking at part B, if I take negative 44 and divide it by 88, I would get negative 1/2. Just double checking, 22 divided by negative 44, I get negative 1/2. So a sub n in this case is going to be equal to 88 times it by r, which is negative 1/2, and it's raised to the n minus 1 power. If I'm trying to find a sub 8, it's going to be equal to 88 times it by negative 1, and that is going to be raised to the 7th power. So that raised to the 7th power is negative 1 over 128 times that by 88. I get an answer of negative 11 over 16. So in this scenario, they gave us A sub 4 is 12, and they gave us the common ratio to be 2. So they asked us to write a rule. All right, I'm not concerned about graphing, but let's use that rule to find the first 6 terms. So our rule is a sub n is equal to a sub 1 times it by r raised to the n minus 1 power. We don't know what a sub 1 is, so we have to find it. But using a sub 4 is 12 is going to help us. So I can write in 12, because that's what a sub 4 is. It's going to be equal to a sub 1 times it by the common ratio, which is 2, and it's going to be raised to the 4 minus 1 power, which is 3. So I can go 12 is equal to a sub 1 times it by 8, because 2 to the third power is 8. Divide everything by 8. A sub 1 is going to be equal to 1.5, or 3 halves. So now that I know what a sub 1 is, I can write my rule and say a sub n is going to be equal to 1.5 times it by 2 raised to the n minus 1 power. And to find the first 6 terms, I'm going to get 1.5. If I put 2 in for n, I will get 3. 3 in for n, I'm going to get 6. 4 in for n, I'll get 12. 5 for n, I'll get 24. And then 6 for n, I'll get 48. So these are the first 6 terms of the sequence with that rule. All right, and now in this particular scenario, they gave us 2 terms in the sequence. A sub 2 is 12, and a sub 5 is negative 768. So what you're going to do is, since we don't know 2 things, we don't know what a sub 1 is, and we don't know what the common ratio is. So we don't know what a sub 1, and we don't know what r is. So I'm going to rewrite these 2 terms with respect to the rule formula. So in the first one, it's going to be 12 is equal to a sub 1 times it by r, and it's raised to the 2 minus 1 power, which is just going to be r to the first. The second one is going to be negative 768 is equal to a sub 1, and it's going to be times it by r raised to the 5 minus 1, which is 4. So again, it's kind of like when we looked at solving systems for exponential functions. I'm going to look at r as the smaller of the 2 powers, so I'm going to solve for a sub 1 in this particular equation. So 12 over r to the first is going to be equal to a sub 1. What that does is I can substitute that into the other equation. So negative 768 is going to be equal to 12 over r times it by um, r to the fourth. Since I have same base values of r, I can subtract the exponents. Now I get negative 768 is equal to 12r to the third. Negative 768 divided by 12 gives me negative 64 is equal to r cubed. Taking the cube root of both sides, I can now say that r is negative 4. To figure out what a sub 1 is, I'm going to substitute that into this equation here. So now I got 12 over negative 4. Negative 3 is a sub 1. So now I have a sub 1. Now I have r. I have all the information to write my rule, which is a sub n is equal to negative 3 times it by negative 4 raised to the n minus 1 power. Last thing we're going to take a look at is being able to find a sum of a finite geometric series. So once you know that the series is geometric, you can use this formula. S of n, so however many terms there are in the sequence, is going to be equal to, first off, a sub 1's on the outside, and it's going to be multiplied by the quotient of 1 minus r raised to the n power divided by 1 minus r. Okay, so looking at an example here, so in this particular one, there's going to be 10 terms to the series, so it's going to be s of 10 is going to be equal to, all right, a sub 1 will, if k starts out with 1, 1 minus 1 is 0, 3 to the 0 power is 1, so a sub 1 is going to be 4. And then inside the parentheses is going to be 1 minus r. Now, I can see that this kind of looks like my rule, a sub 1 over r raised to the n minus 1. So that's like what the rule is for a geometric series. So that's how I was able to kind of conclude like, oh, that's where I get 4. So this kind of means that, oh, r must be 3. So this is going to be 3 raised to the n power. Well, there's 10 terms in that sequence, so it's going to be 3 to the 10th power, and it's going to be divided by 1 minus 3. So, utilizing order of operation, this is going to be 4 times it by, in the numerator, I'm going to get a negative 59,048, and then it's going to be divided by negative 2. So when I divide those by negative 2 times by 4, I get 118,096. So that is my sum of those 10 geometric sequence values. And that is being able to analyze geometric sequences and series. Hope this helps. Till next time.